All right, I'm just continuing with Unit 7, Section 3, volume to volume problems. My computer locked up, so I had to stop recording. So you had the part 1 video, and we only missed there's the last two problems, number 9 and 10, which I'll go over with you right now. Okay, so let's pull up my tools here. All right, so it asks you about the volume of oxygen and nitrogen. All right, what volume of oxygen is needed to react with 50 milliliters of nitrogen? Okay, well, considering that we're dealing with gases, okay, and 1 mole of any gas at standard temperature and pressure is equal to 22.4 liters. So we're dealing with liters. So we need to just convert our 50 milliliters just to make it easier to liters. There's 1,000 milliliters, and every 1 liter, that cancels out your milliliters. And that is going to give you 0.05 liters of your nitrogen gas. So that's what we're working with. And remember, now we got to figure out our volume. Number of moles from this volume that we have. All right, so we know we have 0.05 liters of nitrogen gas. All right, and we said for 1 mole of any gas at standard temperature and pressure is 22.4 liters. All right, your liters will cancel out, which will leave you with moles. So we're dealing with a very small number here, 0.002 moles of our nitrogen gas. All right, so now we need to look at our ratios, since now we know how many moles we're dealing with. And remember, we're looking at oxygen and we're looking at nitrogen. So here's our ratios, nitrogen to oxygen. In our problem up here, there are 2 nitrogens to every 5 oxygens. But look, we've only got 0.002 moles of nitrogen that we're working with. And they're asking us about how many we'll have for oxygen. So set up your molar ratios. Okay, and then you'll solve for x. 2 times x is 2x. And when you take 5 times 0.002, you get 0.011. And then just solve for x. And x is equal to 0.0056 moles of oxygen. All right, so we know how many moles we have, but we need the volume, so we got to convert this back to liters. So next step is that we take our 0.0056 moles of O2, and we said any mole or any gas at standard temperature and pressure is equal to 22.4 liters. Cancel out our moles. And when you do the math on this one, you should end up with 0.125 liters. But this problem throws another monkey wrench into it because they want it in milliliters. So you just need to convert this to milliliters, which basically is you're multiplying it by 1,000. But just to show you the conversion factor here, 1 liter is 1,000 milliliters. That allows you to cancel out your liters, and you multiply 0.125 by 1,000, which will give you 125 milliliters. A little tedious. Some of y'all didn't even have to do that just outright. You could have figured it out by looking at the answers, but that's how you get 125 milliliters for this problem. All right, our next one's a little easier. To the next page here. There we go. Number 10. This is the last problem for this section of the notes. All right. So what mass of dinitrogen pentoxide, so there's our dinitrogen pentoxide, can be produced with 22.4 liters of nitrogen? So that 22.4 liters should be very familiar to you because remember 1 mole of any gas at standard temperature and pressure. And what do we say standard temperature and pressure is? 1 atmosphere at 0 degrees Celsius. So we know we're at standard temperature and pressure equals 22.4 liters. So guess what? That's 1 mole. All right, so we're looking at, so we don't need to do any conversions or whatever. We already know, how many moles of nitrogen we have. So now we need to look at our mole to mole ratios. All right, so we're looking at nitrogen versus our dinitrogen pentoxide. All right, so in our equation here, it's 2 nitrogens for every 2 dinitrogen pentoxides. Hey, look, it's basically a 1-to-1 ratio. Easy peasy. What you have for one, you're going to have the same for the other. So if there's 1 mole of nitrogen, you know there's going to be 1 mole of the other one. So we don't even have to do the cross multiply. We know we have 1 mole of dinitrogen pentoxide. Now in this one, they throw a little curveball. This one's not asking you for the volume, it's asking you for the mass. So you're going to have to figure out how many grams are in 1 mole, which is just a mole to mole. That's just a molar ratio. The molar mass. Molar mass of dinitrogen pentoxide. So nitrogen has a 14 on the periodic table. There's 2 of those, so that's 28 grams for that. Oxygen is 16 on the periodic table. There's 5. So 16 times 5, what did I get for that? 80. And when you add 28 and 80 together, you should get 108 grams per mole. And since we're only dealing with 1 mole, 108 grams is our answer for this one. Okay, that's all the problems for section 3, guys.